This video will explain molarity and goes along with the packet I gave out in class. If you're not in my class, you can still learn from this since I put all the problems on the screen. Okay, so what is molarity? Molarity shows how concentrated a solution is. So if you take a look at the orange juice on the left, you can see that there's a lot of orange concentrate in it, and then if you add water to it, you would dilute it. So there's the same amount of orange, but there's more of a volume of water, so it actually is diluted, so it kind of has a lower concentration. Molarity allows us to express concentration with numbers. So that's what this is all about. Is it more diluted? Is it less diluted? So there's a formula for molarity. It is big M equals molarity. Whenever you see a problem that has a big M in it, just think molarity. So what does it actually mean? Well, big M stands for moles divided by your volume. In this case, your volume is going to be liters. So you should also see it as moles per liter. This is the packet that we will be using. And if you flip to, I think it's page 189. Either way, take a look at what's on the screen here. The first question says, what is the mass of potassium phosphate is required to prepare 4 liters of 1.50 molar solution? So notice how it's asking you to find mass. Well, you know that mass is grams. Liters, it's also given, and then it also gives you molarity. Now, take a look at what it's asking you to find. It says if you're asked to find 1 unit, so you're only asked to find grams, then what you're going to do is you're going to actually start with 1 unit. And that's what the second part is. So what you're actually going to start with is going to be the 4 liters. And then you're going to use the 1.5 molar solution later on in the problem. Now look at the next one. It says what volume of the 0.750 molar solution can be prepared using 90 grams of the ammonium chloride. So again, it's asking for volume. That's where the L is. And then the 7.5, remember that means that it's moles per liter. And then you're given grams. Okay. So you're asked to find 1 unit again. So that means you're going to start with 1 unit, and that's why you're going to start with 90 grams of ammonium chloride. All right, the next one's a little bit different. In the next one, it says if you're asked to find something with 2 units, start with 2 units. This is only if you're looking for molarity. So the question says, what is the molarity of a solution that contains 85 grams of sodium sulfate in 325 milliliters of solution? Okay, so let's take a look at that once the video catches up. All right, here we are. So remember, molarity is moles per liter. Now, what is the closest to moles in the problem? And you can see that I'm starting to write 85 grams. And the reason for that is you know that 85 grams can be converted into moles. So that's why it goes on the top. And then the 325 milliliters, that's very similar to the liters, and that's why it goes on the bottom. So what you would do here is you would convert your grams to moles, and then your milliliters to liters, and then you could do the problem. Then you can divide and get the answer. Okay. So let's actually run through a problem. This one, it says, what mass of potassium phosphate is required to prepare 4 liters of a 1.50 molar solution? All right, so what are we looking for? All right, we're looking for the mass. It's 1 unit, so you want to remember that you're only going to start with something that means 1 unit, which is why I'm picking the 4.0 liters over 1. Now, if you take a look what I'm writing next, you can see the 1.5 is going to be written down, and that's moles over 1 liter. That's your conversion factor that you use. And you have to remember every time that you see the big M, you have to remember that means moles per liter. Now, look at why I put it this way. Liter goes on the bottom so that the 4 liters, the L over there, will cancel out. And I'll show you that in a second. So again, remember the moles per liter. All right, there's the liters canceling out. And then you do the next step. Now remember, we're looking for what mass. So if you notice, I'm going to put moles on the bottom for the potassium as we're writing it in there. And then on the top, you're going to put the grams of potassium phosphate. And we need to figure out the molecular mass. This is a little review to remind you on how to find that. And once you have the molecular mass, you're going to put it where the grams are. All right, so that equals 1,273.62. We need sig figs. So the 4.00 liters, we need to simplify that down. So we round it to 1270. And that's your answer. All right, next one. What is the molarity of a solution that contains 85 grams of sodium sulfate in 325 milliliters of solution? So again, we're looking for molarity. You got to write this down. You got to write down what molarity means. So it's moles over liters, and that's what we're looking for. Again, what's the closest thing to moles? The grams. And then what's the closest thing to liters? That's the 325. Now, the next thing is you need to convert. So we're converting from grams into moles. So we're going to figure out the molecular mass again. And there we go. All right, so it's 142.05, in case you can't read it. And then you put the 1 mole on the top. Now that cancels out the grams. All right. Now, we now have moles on the top, but we have milliliters on the bottom. So the next step is to convert from milliliters to liters, and you just do the 1,000 conversion that you can see there. That cancels out the milliliters, and that'll give you 1.84 moles per liter. That's it.